Okay, good morning. So now I am this video lecture I am making for the research scholar who are writing the coursework of the subject code, that is this one. This is ME2403 control and drives for solar system. So I have seen for last few years question paper. So there one problem is common, which is this find out the output of a PID controller. So this problem I am going to solve. Okay. So here this is a PID. From the error function you have to estimate the output. So this is the error function. Graph is plotted. So Kp is 5, Ki is equal to 0.7 and Kd is equal to 0.5, and initial condition is initially, that is, error is 20%. Okay, so the output is 20%. So that is the initial condition. So now I am defining. So your Kp, that Kp is equal to 5, Ki is equal to 0.7, Ki is equal to 0.7 and Kd is equal to 0.5. Kd is equal to 0.5 and your initially it is 20%. So now what we are going to do, first we will calculate. There you see the error function. This is the error function. So error having three segments. One is 0 to 1, that is increasing. Error is increasing. This x-axis is time, y-axis is percentage. So 0 to 1, it is the error is increasing, and 1 to 3 it is constant, and again 3 to 4 it is reducing, and at 4 seconds it becomes 0. So first we will find out the definition of this one. This error means mathematically we will try to write. So you see, at t is equal to 0, E is equal to 0. At t is equal to 1, E is equal to 1. So how to find out the equation? So this is the t axis. So it is 0 and 1. I am writing as a vector, and E is equal to what? At 0 is equal to 0, at 1 is equal to 1. So now if you give a plot command, t versus E, so on plot will come. And now I am going to tools. This is the tools and basic fittings. And here this is a linear equation and show equations. You see, it is y is equal to x. That means the equation is E is equal to t. Y here means y-axis means E, x-axis means t. So the equation is y is equal to t. So I am writing that equation for the segment, that is t between 0 and 1. The equation is E is equal to t. Okay, this is the equation. Okay, now for the second part, the second segment, that is 1 to 3, that is E is equal to 1, it is constant. So for 1 to 3, your E is equal to 1. Now I am going the third segment, that is 3 to 4. So at 3 E is equal to 1, at 4 E is equal to 0. So let us the same procedure. So I am writing t. So t is 3 and 4. and my error here is 1 and 4 is equal to, at 4 is 0. I am giving same command, plot t comma e. So this is the plot. Now again I am going to the tools, basic fittings. It's a linear equation and the show equation. You see, so my here what is I am getting, y is equal to 4 minus x. So that means e is equal to 4 minus t. So for t, so 3 to 4, my 3 to 4, my equation is e is equal to 4 minus t. Okay, so I got my error function definition mathematically in 3 segments. Okay, now what will be the output of a PID? So that is a proportional part, there will be a derivative part, and there will be integral part with the constant. So that we will be solving. Okay, so now first I will estimate it for 0 to 1. Okay, so my what is the equation? That in general this P is equal to, that is the output, is equal to Kp into that error function, Kp into the error function, plus Kp into Ki, Kp into Ki into integration, that integration of that error function with respect to t, from 0 to t, from 0 to t. Okay, plus now differential part, this Kp into Kd into differential that error function with respect to t. Okay, plus the constant, that is P0. This should be the output. So now I am calculating for the first segment. Okay, that means from 0 to t is equal to 0 to 1. So I am writing it. I am taking one symbol. So SYMS, that is symbol t. Okay, I am taking that. Okay, so now my P1 is equal to, I am writing the same thing, Kp into E. That E means that is t basically, because from 0 to 1 it is t, plus Kp into Ki into integration that t. Okay, I will integrate that t from 0 to t. Okay, then plus Kp into Kd into differentiation of that t. Okay, differentiation of t is a first order differentiation. Okay, plus the constant. The constant is here how much? The constant was initially it was 20. So now this is the my so what it is telling, I forget to put that into sorry. So it is solving. So this is the P1 function. So you can remember, you should remember this. This is the P1 function. Okay. So now at the end of P1, sorry, at the end of this curve, this is a second order, means it's a parabolic curve. Okay. So now at the end of this curve, what should be the initial value? So here the thing is only the integral part will contribute for the accumulating the output. Okay. So now that I am telling P1 1 at the end of the interval, that is equal to what should be, only I will take the integral part, remaining thing I will not take. So I am taking only the integral part, this part I will delete. Okay. So it is coming that, and that is at t is equal to 1. So substitute this P1 at t is equal to 1. So this is my initial condition for second part, second segment. Okay. So that means so here instead of this it should be 87 by 4. Now this is P2. Okay, and if you see our definition for second segment of the error function, your E is equal to 1. So instead of t I have to put it here 1. Okay. Okay. And this should be 1 to t. Okay. Again that I am copying, that's why the problem. Okay, here I will define one f is equal to 1. So now I will paste it. Instead of this I will put f. I will put f. Here I will put f. Here also I will put f. Okay. Empty symbol. Okay. So this, now it is coming, so this is my P2. So for the second segment of the function, it is showing a linear function. Okay. Similarly, so that is from 1 to, the second segment is 1 to 3. Okay. So now what should be the initial condition for the third segment? So that is, I am telling P2 3. Okay. So that only will be contributing, as I earlier told, is only the integral part. So I am deleting this. So this is the so this should be anyway. I am simply telling P2 so this is your only with the integral part. So now substitute P2 with, at the end of the interval it is 3, so I am substituting that. So now the initial condition is this one. So now I am going, if I going to the third segment, so my function is equal to, what is the function for the third segment? That is 4 minus t. Okay, so that should be 4 minus t. I am writing. Now I am going to for P3 is the third segment. Okay, so this is my P3. So now this one, and this should be starting from 3. It should be like this. Okay, remaining things are as it is, and this function, this constant should be 115 by 4. Okay, so again this is the parabolic function. So what should be the after that, after this interval 4, your error becomes 0. Okay, then what should be the value that time? Output value should maintain a constant value. So what should be that one? So for that also that also from coming from the integral part. Okay, so I will delete this part and this part. So this is my integral part, and now I will substitute this. I will substitute this P3 by, because interval was 4. So after 4, what should be the value? So it should be this one. So the value will be maintaining constant at 61.2. Now I am trying to plot. So I am taking 3 variable T1, that should start from 0. The increment is this one. It is going to 1. Then T2. T2 is equal to 1 to 3. Then your T3, that is equal to 3 to 4. Okay. After that it is constant. So I am, for just these things I am taking T4, that should start from 4 to 4 to, say it is, I am taking 6. Okay. So for the first one, first interval, what is the equation we have got? For the first interval, your equation is this one. Okay. So here I am writing, this is my f1 is equal to, this is t1 square, this is my first equation. Now for the second interval, what is my equation? So my P2 is equal to, this is the equation for the second interval. Okay, so I am putting that one, and this is F2 is equal to, this is T2. Now for the third interval, what should be the equation? For the third interval, this is the equation. Okay, so my F3 is equal to, this is T3, yes. So here this is mismatching because it's a vector, so I am putting here a dot, it is better. Okay, what we will do, this first I will expand. I will give a command of expand. So this is the thing, and now in F3 I will write this. F3 is equal to, and this should be T3. Okay, now it took. Now F4 is equal to, as I told, after that it is 60, this one, it will maintaining constant output, so it is 61 by 2. Okay, so my, now the interval and the output function is defined. Now I am giving the plot command. So T1 F1, T2 F2, T3 F3, T4 F4. So this is the final output. T1, F1. T1, F1. Now hold on. Plot T2, F2. You see? Now hold on. Plot T3, F3. So here F3, okay, F3 here, the problem is, here I have not given T3, so now it is okay. Now if I give this command, it will work. So now you see the plot. So your after that F4. So at what is the value of this? Around 30 or something. So plot, if you see T4 comma F4. Let us define F4 is equal to 0 into T4 plus 61 by 2. Now giving plot T4 comma F4. Let us see, it is coming. So now I am giving the you see. So now the output will be your final output will be, it will go like this. In exam you have to draw like this. It is like this, then it is like this, going like this. Oof. So it is like this, then a line here, then it is like that, here coming, here like this, like this. So this in your exam you have to draw this one. This is 16-mark question. Okay, so hope you have understand. Thank you so much.